Part 2. Motion of a moving charge in a uniform magnetic field. In this section, we will investigate the motion of charges in magnetic field and in electric field. As the force produced by electric field or magnetic field are so much larger than the weight of the moving charges, the effect of gravity is often ignored. A. Moving charges in a magnetic field. A charge moving in a magnetic field will experience an induced magnetic force perpendicular to its motion. Hence, there will be no work done on the charge, and the induced magnetic force can only change the direction of the motion, and hence resulting in circular motion. Thus, Bq4 equals mv squared over r, which gives r equals mv over Bq. So, charges of different momentum, mv, will travel along different circular paths of different radii r. A spectrometer mentioned on page 207, Let's Begin section, makes use of this principle to separate charges of different velocities. In example 16, you have to apply the above result to calculate the radius of circular path and then calculate the period of the motion. And note that for part C, as the direction of magnetic force and the particle motion are perpendicular, there's no work done on the charges. In example 17, an electron is first accelerated from rest by the potential difference to attain a high velocity. We learn on page 63 that a charge passes through a potential difference V will result in an electrical potential energy change of QV. In this case, becomes kinetic energy of electron. When this fast-moving electron enters a magnetic field, it performs a uniform circular motion. From the radius of the circular path and other physical values, we may calculate the charge-to-mass ratio. In the solution, we calculate the initial velocity of the charge before it enters the magnetic field. And for part B, from the equation of motion, by measuring the radius of the circular path, r, we may be able to calculate the charge-to-mass ratio. And since we know the charge of an electron, which is 1.6 times 10 to the power negative 19 coulomb, we may use this experimental result to calculate the mass of an electron. For the exam link question, a positively charged particle performs a uniform circular motion inside a uniform magnetic field. The question is quite straightforward. I'm sure you can manage it yourself.